Today we're going to talk about the ideal gas law. We will be using the ideal gas law along with our stoichiometry, converting from grams to moles, to do a lab where you'll be making an airbag. So the ideal gas law is the mathematical relationship among pressure, volume, temperature, and the number of moles of a gas. Nothing is held constant. There's only one set of conditions. And so if you notice in this equation, we have 5 letters, 5 variables. We're going to go through what each one means and do the units and then do an example problem. So P stands for pressure. There are different units for pressure. The units we are going to use is kilopascals. V, we should all be familiar with, its volume. I know many times in lab we use small volumes, but for the ideal gas law, we will be using liters. N stands for moles. And the units are the same, they're moles. Now, R is a gas law constant. And you just have to memorize this with the units. I'm going to give you the number and the units. So it's 8.314 kilopascals times liters divided by moles times Kelvin. You just need to memorize this number. T is for temperature. And the units are Kelvin. So I know you're used to temperature being in degree Fahrenheit when you watch the news. In lab, our thermometers measure in degrees Celsius, but we're going to use Kelvin. And so the temperatures, I will always give you the temperatures in Kelvin. You don't have to do any conversions. And you won't have all of the units. The only type of conversion you might have to do is milliliters to liters, or in terms of the lab, you'll have to convert moles to grams. So our example problem, how many moles are in a 0.500 liter volume of a gas at 250.2 Kelvin and 105.0 kilopascals? So I like to write down what information I have, make sure I know what all these variables stand for. So we're looking for moles, which is N. We have a volume of 0.500 liters. Temperature is 250.2 Kelvin. And our pressure is 105.0 kilopascals. And the R value is not there, you just have to memorize it. So PV equals nRT. P is our pressure, 105.0. V is our volume. Trying to find N. R is 8.314. And our temperature is 105.0 kilopascals. So if I want to solve for N, I'm going to divide both sides and I actually don't, this should be temperature here. I put the wrong thing there. should be 250.2 Kelvin. So I'm going to divide both sides. So you would multiply 105.0 times 0.5, multiply 8.314 times 250, and then you divide. N will equal, and I need to look at sig figs. Least number is 3 sig figs with the volume, so 0.0252 moles for my answer. We'll do another example. Calculate the volume. So we want to find volume occupied by 0.234 moles of ammonia. This time we know what gas we're working with. At a temperature of 303.2 Kelvin and a pressure of 85.8 kilopascals. So I write down my ideal gas law and I plug in my values. So pressure is 85.8 kilopascals. I'm solving for V. N was given as 0.234 moles of ammonia. R we memorize is 8.314. And the temperature is 303.2 Kelvin. I'm going to divide both sides by the pressure. That'll cancel, and then you will be left with your volume. You do need to look at sig figs. And so the least number would be 3 because my moles have 3 sig figs. My pressure has 3 sig figs. So it'd be 6.87 liters of ammonia. You have practice problems to do. You will have a daily assessment, which will be the last stoichiometry daily assessment. And then we will use this again when we get to our lab discussion for Goldilocks and the Three Chemists. As always, if you have questions, please message me in Schoology, attend office hours, talk to me when you're in class also.